start. So I'm going to go over a quick introduction to Fusion 360, which is a modelling software built by Autodesk, who's the bigger software, AutoCAD. But Fusion 360 is a bit different in that you can get a version for free. So it has a paid-for version, and it's relatively expensive. But you can also subscribe for free as a maker or a hobbyist or something like that, and they actually let you use it full power, no restrictions, for free, and they sorry, what's in the eye? That's annoying. The only restriction is, and is in the contract you agree to, is if you earn more than I think it's like £100,000 or $100,000 with it, you have to start paying the subscription, which is kind of like, that's a nice problem to have. If I earn £100,000 of this software, yeah, okay, they can have a bit of my money. Yeah. You know, and it's not that expensive. It's like 50 quid a month, which, if you're burning that much, it's pittance. So the big thing about Fusion 360 is it's a parametric design software. So you can draw something completely by hand and just put in the numbers as you need it, or just drag it and guess it, and then make it that way. Or you can put in the measurements you need as you put them in. So if you want a cube that's 10 millimeters by 20 millimeters, you draw one 20 by 10, and then you've got your baseline, and everything bases off that. Also, all the measurements you put in allow you to then can be changed after the fact. So say you went, I needed 30 millimeters instead of 20, you can go back in and just change that, and it all resizes for you. So you can do all the dependency-based bits on that. So what I'm going to start with is quick go over the interface here. So the central bit is just the main work area, where you've got as much space as you need with it, with a spacing grid. And to move around, you use middle mouse click, which is why you need a mouse for this. You can't do this with a touchpad. I've tried, it doesn't work. But middle mouse click clicks and drags the piece around. Left click is for select, right click is the extra menu. So, and then there are modifier keys, so control middle click, control one of these. Yeah. Shift middle click is rotate. So you can rotate the piece around and look all the way around it. And if you end up with it upside down, you have an orientation system in the top right, and this has a home button, which will scale everything to fit back on your screen quite happily, so you know where you are again. Yeah. This also has, you'll notice there's on this box there's a highlighted corner, and you can actually highlight different sections all the way around it. So say I want to look at it from the other angle, you mouse over that and click, and that will rotate to view that piece. So you can actually look at the various areas, front, side, rotations, everything like that. And you can also rotate by clicking and dragging on it. So if you haven't got shift key available, or you're showing it some other way, you can pull it up like that. So next bit you've got is your top bar, which has all the various bits and pieces you can do in this particular mode. So Fusion 360 has a couple of different modes, like model, which is for creating the model, patches, which is for, I've not actually used those, but this is for doing clever stuff with 3D models if you've got one that's come in that's wrong, you've got issues with. Render allows you to go from a 3D model into a actually rendered object. So you can see here the airplane has the propeller has a wood effect, and the nose cone is actually metallic and has reflections, and you can do some really, really nice renderings of various bits and pieces. You can do animations. So if you want to see the insides moving, say if you've got gears and stuff you've modelled and they rotate, or exploded diagrams for whatever. Then they have simulation, which is not simulating as in the animation and making sure things move, but stress simulation. So in the example here, these are the front forks for a bike, and it shows where where you get some extra stresses along the side from bits moving, from just putting torsional strength in various bits. And you can do some really heavy modelling on that. You need a bit of a machine to do that though. This machine won't do it. The other nice part on this is the CAM part of it, so computer-aided manufacturing. So with this, with this one piece of software, you can go through modelling the item, rendering it so you can show it to your boss, simulating it to prove that it won't break under stress, and then go all the way through to actually manufacturing it at the other end with a machine, with either a 3D printer, because it will support 3D printers, or with a CNC mill. And then it's also got the ability to pull in drawings from various other areas. So I'm going to be going on the modelling side of things, because going into the CAM side and the animate and the rendering side is a whole other kettle of fish that just is quite complex, and let's keep it slightly simpler. So the basic idea of when you're actually working in this, why have I got Steam running? Why buy Steam? Is you can go from either a sketch, which is a two-dimensional drawing, or bring in a three-dimensional object such as a box or a cylinder. So if you've got I need to make something quick, you put in a box and then start cutting bits away from it. So if you need a junction box, you can do something like that. And you can do all sorts of weird things like put threads on things and actually model the threads in and make them work. So you can see the change of them for simulations. A lot of the way I go through things is with the sketch first. So with the sketch, you literally get a two-dimensional drawing and then draw on it as if you would with any other drawing package, such as Inkscape or Illustrator, anything. And you can actually go from those sort of pieces of software to this. So if you've got a particular whole layout that you need for, I don't know, you've designed the mounting points for something and you need to mill it into it, you can then draw it and that pull in the diagram for the other software and just select the bits you need to cut. So first thing I'm going to build is this piece, which is a little spacer for the large bolt style keys, which have an oval instead of a single hole. Yeah. Because I have a Swiss Army knife style key holder, but with the central eyelets of those, it's so long that it causes it to wobble in there and it gets caught and everything, and it just doesn't swivel nicely. So I'm going to go over how I designed this. So I'm going to start off with a completely empty empty model, and the first thing we need to do is create a sketch. So go onto your two-dimensional bits, click Create Sketch, and then you can choose which 3 planes you want to actually go on. So you can either do YZ, XZ, or XY. Don't ask me why XY is either that way, I don't know either. But XY, Z is normally up in terms of models. Yeah. So I'm going to use X and Y so that things make sense in my mind. So you select the box you want there, like that. At which point this has set you up for drawing on the grid. Hello. So the first bit we need is obviously a layout for the actual round bit. So a couple of different ways of doing this, but as we want it to be round at the end, we'll start with a circle. So pull in the circle, and you can either click the circle tool at the top, or press C. That's a shortcut for that. At which point, pick a centre and drag it out. And you can see this gives you a box to put in the dimensions you need. Now this is going to be much bigger than I need it, but for an example, let's use 75 millimeters. So type in 75, press enter, and then you can place the measurement wherever you want. So that gives you a nice simple circle, and if that was all you needed, you can now click stop sketch, and you have that sketch in free space. If you need to get back into your sketch, say which we do now, there's the option bit on the left hand side gives you access to all the different bits, like all your planes and your origin and extra views. You did that, so you can customize extra views. But you see sketch 1, which highlights the circle. So if you double click that, it'll put you back in it. There. So we'll need a second circle for this. So let's pull up another circle and let's put it there. So you can now specify, no, I'm not going to specify the diameter here, I'm just going to click there. So I've now got a randomly sized circle. So the next bit I need to do is pull in a dimension. So in the two-dimensional sketch option, you can go to sketch dimension or press D, and then you can click that, which will give you the ability to set that I want to define this dimension. Click the place where you want the actual dimension to be right, and then if you click another dimension in view, it will set it to that. So now, that's now completely set. That's now set to be that one. So if I go and change this and press escape to get out of the tool I was using, so if I change this to 16, they both resize. So you don't actually need to, so unlike some software where you need to define all your sizes and stuff before you come out, you can actually just stop there and carry on elsewhere. Now the one problem here is, I can move this anywhere currently, but I want it to be at the same point as that.
Constraint.
Yeah, to constrain it. So this has multiple different constraints that are available for all sorts of different bits. And if you're unsure of which ones you've got, which ones you can use, if you select, so you've got all these like symmetry, equal size, smooth joins, tangents, all these sort of ones, concentric ones, so you can make circles within circles quite easily. What we need is, I think the horizontal vertical is going to be the one that I want. So you click your constraint you want, click the first one, click the second one, and that should be it. And now if we move that one. So I've not constrained it horizontally, but now there will always be horizontally linked. So the next thing that I need to do is to join the two. In fact, actually, let's go for the distance between them, because joining them is a bit easier. So, as earlier, press D, and that will pull up the dimension tool. Click once, click twice, and now we have a dimension between the two. And let's make this one, pick a random number.
120.
120. There we go. So that's now fixed at 120. So now they're constrained horizontally and vertically, and oops, if I click it correctly, they will forever be linked like that. So to finish this off, we now need to join the tops and bottoms of this in there. So we can grab a line and this will give you, so as I'm driving this around, you can see it's sort of snapping to various things like horizontal, tangential, 90 degrees, and just giving me degrees on it as well. But what I can do is just go over here and click that. So that's now joined those two together at a random point. the next thing to do is to add a constraint to that. So I've got pick up tangent, take that one, and make it tangential to that. And then, I'm going to take out, pick up tangent again, click line, and make it tangential to that one. And now, we repeat the same thing for the other side. So drag the two, and you can see it's filled in that central gap now. So we recognise that that's a completed solid. So that's something you could then extrude out in the three-dimensional view. So let's quickly pull these two in, tangent there. And if you needed this to be at a particular point in this, you could lock this to the other end to say perpendicular. I don't think it's going to let me. No, it's not going to let me drop them out. Never mind. There are some constraints that just it can't do, and there are ways around that. If you know your constraints, you can do all this with right angles. But that gives us a nice simple way of pulling together, and now we've got that piece. So from that, I'd say that's almost good enough. Yeah, that's good enough for now. So I've just clicked Stop Sketch, which now pulls me back into the three-dimensional view, and you can see that we've got our piece, our sketch, just there. So now we need to create a body from this. So this is a solid object from that. So in the three-dimensional tools, there's quite a few different bits and pieces for that, but the one we want is the extrude one. And for this, you select the faces you want all together, and then you can either drag it by hand and say I want it that roughly that size. You can also change the skew, so you can make some really weird sizes. It does get a bit annoyed by infinity, but so you can actually do really unusual shapes straight off, and that's like one operation. You've got a pyramid almost. Let's cancel that. Press escape and it cancels whatever you're doing. So let's pull this back in again. Select all three, and then here we can determine the size we want. So let's go 10 millimeters. Done. We now have a 10 millimeter disc, not quite disc. Tablet. Yeah. I wouldn't want to swallow this one. It's a bit big. So. And I've just screwed up my view. Let's go back out. There we go. Back to the original view. So the next thing we need on this is a hole in the middle. Now there are two ways we could have done this, and in fact I will. You can either go through both of them. You can either create a new sketch, and this you can either do it off one of the baseline ones you've got there, or do a sketch on the face. So this will be then constrained to that object. So let's click there. And then what we need is a hole in the centre of this. So first off, we're going to have to find the centre of the piece. Now the easiest way to do this is to sketch a line. And if you see where I get to the midpoint, it pulls up a little symbol there with a triangle, which means midpoint. So if you click there, and then drag down at 90 degrees to the other midpoint, that's now a perfectly central line. And in fact, you can see it's snapping extra blue lines to that, with extra bits there. Now this is a construction. This is a proper actual model line now. So you can see that and that are now separate pieces. But you don't want this to be part of the model. So we click it, and we change it to a construction line, which means that it's just on the sketch, there's nothing to it, it's there to help us as a guideline. So now you see it's gone to a dashed line, and that's just by clicking the normal construction box up there. So now we actually want a circle in the middle. So I press the C button to get the circle, and you can see this is snapping to the centre there. And so let's make a hole 45 millimeters. There. So now we've sketched the circle there. Okay? So say that's all right, that's all good. Click stop sketch, and now we cut the hole. And for that, there's no extra different cut tool or anything like that. It's extrude again, but this time you look at the operation, and you can either put a new body in, where you extrude it out, you create a new item, join it, so it will always be there, cut it, which is what we'll be doing, or intersect, which means if you push it inside, you can then, and anything that is intersecting, say this was a different shape and you were cutting a circle through it to get extra contours out of a particular part, then that would just leave that piece there. For this we're going to do cut, and you can just do that. Just drag it through, don't care, done. If you want to be a little bit more stylish and say if you so the thing with this is now 70 millimeters. If you then change the body size to be 80, you will now have not a hole that doesn't go all the way through because it's linked to one side of it. So if you do change the extent to object, click the other side, that's now a hole through the whole thing. And this works with multiple selections. So if you've got 8 holes you need to go all the way through as one operation, just select them with control, click through, done. You can also just say all, which just cuts a hole. But to object I find is suitable for that. And there we go. So that's the initial way of cutting a hole. The other way would be to do it on the original sketch. Now, say I want it. Now, I'll go back to that in a second. Say I made a mistake. We actually have at the bottom here a timeline of all the operations. You've got the initial sketch, the extrude I did for that, this second sketch, and the extrude I did for that. So let's say I need to change the that sketch. You can double click there and it goes back to that point in time. At which point I can change this to be a different size. So the bigger ones were 75 ones. So let's go for 70. There we go. And now instead of having to do everything else after that, re-extrude it, it just continues. It just does all the work it needed to do beforehand. And that's the same for if I go all the way back to the first sketch and change something. So let's make that D1 times 2, and then change this one to 98. Stop sketch. Done. I've changed one number, and now I can change one number and everything will change there. And if I need to go back and modify the extrusion, say for example if I come back here and say add in an extra rectangle, and go to the extrusion step and add in that.
Signpost.
Yeah, now I have a signpost with a hole in it. Don't ask me why it's moved the hole. I know why it's moved the hole. The constraints changed because I've changed that line.
Right.
So I can go back to this, and you can see it's done what I told it to. It's still that line. The construction line I've got is still midpoint of that line to the midpoint of the one it thinks was correct. So what I have to do in this case is make another construction line there, or go across that way, or something like that. That was a very drastic change.
Can you edit that construction line? Move it centre?
Yeah.
Rather than make a new one?
Yes and no. Delete that.
You have to take the constraint off first.
Yeah, you have to take the constraint off to do it.
Right.
So, you know, if you then have... well, actually, yeah, you can do it. Hang on a minute. Is that going to work? No.
Don't worry, put it side down.
Yeah, it then went... Yeah, no, it went, no, I don't know how to do that.
Not the vertical, couldn't you?
Yeah, so I could actually snap that there and take that constraint off. And
do
then
it across the way.
and then literally, and I'm just dragging lines around here.
Yeah.
So this is like, oh, I need to do it the other way, and then we're done. We still have a signpost. So there we go. That's a very quick introduction to that side of things on Fusion. And from this, you can then go from in here. If I wanted to print this now, you'll find that the body of this is under the bodies section, and I can now select that, right click, and save that out as an STL, ready to put into a slicing program for a 3D printer, or try and slice it in here. Although I don't know how to use a slicer in here, so I'm not going to. But it has its own slicer that will work for a lot of 3D printers. I think it does actually work for the
It does have the
I-
Prusa on.
Yeah, it has the Prusa i3 on it, so it will work with one of the printers we've got in here. Won't work with mine. I know for a fact it will work with mine. But there we go. So that's a very quick introduction to Fusion 360. Anyone have any questions? Anything you want me to go back over? Anything you want me to, you saw a button, you went, what does that do?
Do you know what platforms it runs on? I think this is the Linux version.
There is not a Linux version, but there is a Mac version, so there is hope. There's been a lot on the forums. There has been a lot of people going, "Why don't you support with Linux? Because if you support Linux, then you'll get a lot of people in more using it." And I think the reply is, "We've looked at it, and ouch." Because unfortunately, due to the nature of the Linux ecosystem, there is a lot of different things to support. So they'd have to pick one, like say Ubuntu or Debian, and they'd most likely go for Ubuntu, and that would make a lot of people unhappy.
Right.
So I think they've just gone for the solid. Let's just make a more stable piece of software first, and then get to it. And yeah, you can't run this in a virtual machine because it just doesn't quite have the grunt. Unless you've got a really powerful machine. So, yeah.
You could remote into someone else's machine.
What, you're offering the loan of your workstation to that program?
Yeah, you could actually. I was actually debating this with this machine. I'm surprised it runs on this.
Blender doesn't run on my laptop. I'm going to remote it into my desktop.
Cool. This has only got an M3 processor, so it's not even a top thing. It doesn't even have a fan in this laptop, and it's powerful enough to run this. So you can run this. You can run this on a low power system. You get problems when you start doing bigger models. So when you get to this does actually have some demo projects, and this also has that's actually my demo project, not the sample. Design samples. So a few different ones that people have done, and this is now going to cry. My machine is going to cry because that's got a few bits. Oh, it's doing it. It's done it. Actually, that's a lot more impressive, a lot better than I thought it was going to be. But given it, as with anything, with a bit of time, you can get to the level where you can model a complete utility knife, and you can actually move the model. So they've actually put in constraints for the joints for this. So this can go into the level of rigid joints and bits and pieces for actually making things move, and for simulations and for animations. So that's one of the things that you can do with this.
The other thing I like is to give you the timeline for the demo ones.
Yeah.
Go back and follow exactly what they've done.
Nice.
So all of this, literally the last one is position stuff I was just playing with. Autodesk logo on this side, a chamfer somewhere. Oh, yeah, the chamfer on the hole in the middle. All the way back to, composition, multiple compositions, splitting it. All the way back to the Stanley Fatmax fixed blade image that they put into it to sketch from. I don't know if this is in the image. There we go. So there's the image that they pulled in to actually model this from. So you can go from, I have an image of something, say you want to create a model from a game, say well trinket or something from a game, you've got a screen capture of it. You just pull that image in, and then you can sketch over the top of it and do your sketches on top of that, and that gives you the ability to then extrude out and model things as you need there. So I've not done that.
You're doing replacement parts.
Yeah, replacement parts as well.
If you've got something like your washing machine's broken and you want to replace the part for it, you can cut the part using this just by taking a photograph of it and then superimposing everything on there.
Yeah. Or taking or if you've got a particular hole pattern, putting the piece on the scanner, scanning it, and then bringing that in, you've now got the hole pattern you need for the thing you're mounting it to. So yeah, so there's a lot of different things, but that's more in. I don't think this is definitely not something that Fusion 360 only does. That other software will do this as well, but it's the sort of thing you do. I'm not going to say that because no. So yeah, I made a sign with a hole in.
Looks like quite a good program.
Yeah, it's a lot more powerful than you. There's a lot of power hidden in here, but it's relatively intuitive once you get over the initial rope bump. So the best thing I found was watching. Is it Steve Saunders? John Saunders from NYC CNC. He's been using this a lot, and his initial videos of it, he does a how I made a box in 2 minutes. Instead of all the other tutorial program things which are like 2 hours long, and you sit there and you're bored for the first hour because they're explaining how you use a mouse. He goes at it at full speed. 2 minutes later, you have a box with a hole in. Similar to this walkthrough, and there's a lot more people doing. This is how you can do more other things, and you can also do in here. So circular patterns, rectangular patterns, model patterns as well. So if you need 4 wheels on a car, you design one wheel, put it in the right place, and then mirror it 4 times around it. Or you need bearings in a disc. You can model one wheel and extrude it in, circular pattern there. Or on a path. Say you want to put fins in the side of a toy gun or something like that, you can then just say, I want a hole here, and model it. I've not tried these ones, so I'm not going to try them because I'm just going to make a tit of myself. But yeah. Any other questions?
There's a good resource. They've got their own resource for files, but there's another good resource called GrabCAD. Where you can download in. There's lots of models already been created.
Right.
A lot of them in SolidWorks, but you can import SolidWorks models straight into here.
Yeah. So if you need, say, a screw model, you can actually go into pull in a McMaster car component. So it might load eventually, maybe. I don't think so. Never mind. This gives you a little view onto their model store, and then you can pull in like bolts, nuts, gears, motors, large component, I think you can pull. I think there's a model for a forklift truck. If you need to model, say, a warehouse, you can pull a forklift truck model in and make sure that it'll actually fit through the door, because that would be bad. And I've broken it because I've lost the grid. Where's the grid gone?
Lost in space.
Bottom right, in the middle, there.
Ah, there we go. Great. Hey, I learn something new every day. So yeah, you can pull other models into this. The other thing that some people might be happy about, but I actually think it's great, is that the whole thing is cloud-based. So none of these items that I've got here are actually, well, they are stored on my computer because they keep a local copy, but they're actually synchronized to the Fusion 360 cloud storage. And so when you log into your account on any machine, all your designs are there. So you can actually do a design from anywhere.
What's the average kind of file size for something reasonably complex?
Good question.
Can you get to where that's stored? If you've reopened it and saved it somewhere? I assume you can save locally as well as.
I'm not sure. Actually.
You can now. They never used to be able to do.
Right. So there we go.
That was something that came from John Saunders.
Right. Yeah, because he was transferring stuff around, and there was
The servers crashed basically for about 2 days.
Yeah.
And they said I can't use it for a business. It's crashed for 2 days.
I'm sorry about your deadline, but our servers are down.
Yeah. So yeah, then I think it will run offline, but you've then only got your local cache copies. I wouldn't know offhand if and where it saves it. It might tell me in preferences.
What is it that runs off the cloud? Bits of it.
all the file storage is cloud synchronized.
Oh, okay.
So a bit like Google Drive or Dropbox.
But you don't lose the functionality of the program if you're offline.
No, you can use it as long as you've got a local cache copy that you want to work on.
Yeah.
Tom, probably users username app data.
Probably actually.
Usually they drop that there.
Hey, look, Autodesk Fusion 360.
It'll probably be some weird hash Python.
Yeah. Oh, it'll be running Python underneath.
Okay.
Don't know offhand if it's got there.
Not to worry.
No, not there.
Oh, really?
It'll be somewhere.
I'm going to assume they're relatively standard files.
I think they are.
Well, they ought to be, really.
Because it's
with the main
parametric,
files, yeah.
it's just numbers, literally.
Yeah, I honestly wouldn't know offhand where that is.
Certainly as by comparison to a vertex.
I've got my Fusion 360 models on my iPad. I can't edit them, but I can view them.
Okay.
Yeah, and yeah, so there's also the ability to view these items online. So there is my Hub Autodesk. Go on, sign me in, please, with the right password. So, okay, whatever. All those projects, so you can see my RFID wall mount thing, project I was working on before, was there. But there's KeySpacer. And you can upload extra designs and bits and pieces. And actually, here we can you can upload new versions and bits and pieces in here. But you can actually open the 3D you can open the model online. So if you're then going to a design meet or you want to show someone something you designed, you don't have to bring your laptop. You can just pull up your phone or go on their computer. And you can do
Do you want the combination for the toilet?
Oh, yes.
it's on the back of the door. On this side.
Oh,
C902Y.
thank you.
I'll sort that bit out now.
Yeah, a little bit off topic, but I've seen that on the knife, compared to yours, there's different materials on the surfaces.
Yes.
The yellow sections, the blue sections. How does it handle materials?
So materials are used in the rendering side. I don't know if we're running massively over on time. I think I am because it's 12:46.
It would be good to sort of wrap up fairly soon.
Yeah.
Yeah.
So you can put them in. You go into the render side and you can set up textures. But I've played with that exactly once when I was doing their tutorial.
If you right click on the actual model,
I won't ask you to
Oh,
UV
you
on
have
Ah.
texture map controls on there.
Oh, it's actually got appearance there. Never mind.
I won't ask you to UV on the model you just created if you know them.
Yeah, I've done it, but there we go. Actually, right click, appearance, plastic, opaque.
Oh, right,
You
okay.
drag that up to the top box.
And what?
Where's his appearance?
Settings are in no shape.
Probably lighter. So,
Pull green up to the top.
Into there, and then pull it onto the model from there.
So you create a palette and then apply it.
yeah. So
If you double click one of those materials, can you get some further settings on? Nice. What have we got? Reflectance, roughness. Advanced. Oh, go on,
wind. Oh god! If you want a code for this thing, you can. It's got full Lua, Python, everything backends.
Okay.
But
emission, lovely.
yeah, you can do some crazy stuff.
Cool.
So yeah, this is stupidly powerful. When you do the rendering, you can choose to do cloud rendering or local rendering. Cloud rendering's quicker.
Yeah.
Really?
Depends.
For big models, it's a lot quicker because they just throw it into one of their big servers.
16 Titan Blacks.
That'd be a nice problem to have. But yeah, there we go. That's Fusion 360 in slightly longer than we expected.
Very cool.
Right.